that was drifting too slowly. So you can see on the left, it's the motion of the ice as observed from a satellite, and on the right we have the motion of the ice observed, simulated by the model, and with the default parameter values, the model was on average too slow. And then I calibrated this parameter using data assimilation to see what happened, and the results with the calibrated parameters was much better. What is interesting here, and also I think fascinating, is that I didn't have to do anything manually. I just entered the algorithm into the sea ice models, and I let the magic take place, and the value that was returned by the data assimilation method that I'm using were the one that gave the best fit to observation that we have. So here we are. I'm convinced that we will need to keep using both observational sources and model estimates to improve our understanding of sea ice and to understand how climate changes at the poles. And my point here is that there exists a whole mathematical theory that is called data assimilation that tells us how we should merge observations and models together. And at least I gave 3 examples suggesting that data assimilation is a promising field to explore to answer these questions. Thank you very much.
Thank you. Is there any quick questions for Francois? No. Then our next speaker has cancelled, but there was a speaker earlier that we missed, and I'm not sure if we'll be able to get them online now. Are you able to go online now, Du Ziheng?
Brief introduction of my presentation. It's about the spatial and the temporal variations of the total mercury in Antarctic snow along the transect from Zhongshan Station to Dome A. This is the introduction about the background. We all know that mercury is the most toxic metal, and it can be transported globally, and it can also be accumulated in the food chain to create the big pollution harm to our health. We all know that the Minamata disease happened in 1950s and 1960s. It's a very big disaster for Japanese people's health. And this gives some brief review of the research on mercury in snow and ice in Arctic, Antarctic, and Tibetan Plateau. And this is the paper published by Bolton in 1998. It showed that during the 1950s to 1970s, higher mercury concentrations were found in the summit snow layers. And another paper published in 1998 in Nature, we give some interest about the Arctic mercury deposition event, and this may be a big harm to the people's health lived in Arctic. Professor Sean Kang did a lot of similar jobs in the Tibetan Plateau and some publications. Antarctic, we can find that in some places it did similar work, but in this region, from the Zhongshan Station to the Dome A, the highest point of the East Antarctic, now it's blank. So we want to check whether what it can do in this region. And this is the sampling and analysis. From the Zhongshan Station to Dome A, the distance is more than 1,200 kilometers, and the elevation rise from the sea level to more than 4,000 meters. And we get 13 ice snow peaks and more than 585 snow pit samples, and all the samples has been analyzed for mercury. This is analysis motion and some measured and direction limits. Okay, let's see the results and discussions. First, we compare our concentration levels with other sites in Antarctic. We find that our concentration levels is similar with the joining motherland from here and to the Dome Fuji, and also similar with the summit in Greenland by Bolton, but much lower than McMurdo and the Dome Sea. We also did the spatial variations of the total mercury, and we can find that this from the coast to the inland region, we find it. This is for the surface snow, and this is for the snow pitch. You can find that with the distance increased at the coastal region, it showed a decreasing trend both for the surface snow and the snow pits. But inland, it showed an increasing trend with the distance increase. We also found that the total mercury in surface snow samples is higher than the snow pits and may be caused by the post-depositional effects. And we also did some assessment of the annual total mercury deposition amount in the plateau region and also for the entire Antarctic ice sheet. And this is the values assessed annually deposited. Here is 0.414 for the inland region, and for the entire Antarctic ice sheet, it's 0.55. We also studied the possible influencing factors, and the temperature may be one region. We know that in the inland region it's much colder, and may be useful for preventing the re-evaporation of the total the mercury from the snow layers to the atmosphere. And we all know that in the inland region, the diamond dust is a special precipitation style, and it's maybe also good to keep the mercury into the snow layers. And also we found that the concentrations of reductant and oxidant, the